This video breaks down the 7 levels of aircraft carriers, from the earliest flight deck experiments to the next generation of unmanned, networked naval air power. Level 1. Early flight deck experiments. Level 1 covers the first attempts to put aircraft on ships. These were not carriers as we think of them today. They were modified vessels or temporary platforms built to test the idea of naval aviation. Examples include HMS Furious, HMS Argus, the USS Langley, and the early Japanese carrier Hosho. Many of these ships started life as cruisers or merchant ships. Their flight decks were short, their elevators were basic, their catapults and arresting systems were experimental. The aircraft that operated from them were fragile and light. Pilots often had to land on simple deck wires or rely on strong headwinds to slow down. Early carriers could launch and recover only a small number of planes. Their operations depended on calm seas and favorable weather. These ships helped navies understand how to organize deck crews, manage takeoffs and landings, and store aircraft safely on board. They also showed the potential of naval aviation. Even though the designs were crude, Level 1 carriers were not fast or heavily armed. They were vulnerable to surface and air attack. Their air groups were small and inconsistent. But they marked the beginning of a new form of warfighting. Without these experiments, later carriers could not have existed. Level 2. Early World War II platforms. Level 2 includes carriers built during the 1920s and 1930s, as navies refined the concept. These ships were more capable than the early test platforms. They carried larger air groups, used stronger decks, and incorporated new features that improved safety and efficiency. Examples include the USS Saratoga, USS Lexington, airbases Courageous, MS Glorious, and the Japanese carriers Akagi and Kaga. These ships were often large and fast for their time. Their hulls were sometimes based on battle cruisers or heavy cruisers, giving them better speed and protection than Level 1 ships. They introduced improved arresting gear, more reliable elevators, and better aircraft storage arrangements. They could conduct sustained flight operations and support coordinated strikes. Their aircraft were still light by modern standards, but more capable than earlier biplanes. These carriers placed a heavier emphasis on doctrine. Navies experimented with scouting, coordinated attacks, and fleet screening. Flight deck procedures became more organized, maintenance routines improved. Level 2 carriers were not heavily armored, they carried outdated fire control systems. Their aircraft lacked range and payload. But they shaped the early approach to carrier warfare and prepared the way for the more powerful ships that appeared during World War II. Level 3, World War II fleet carriers. Level the 3rd of March Cass, the arrival of the first fully capable carrier fleets. These ships could launch large numbers of fighters, bombers, and torpedo planes. They became central to naval strategy during World War II. Examples include the Essex-class carriers of the United States, the British Illustrious class, and Japanese carriers such as the Shokaku and Zuikaku. These ships played major roles in battles across the Pacific and Atlantic. The Essex class carried a strong air wing and had better deck handling procedures. The Shokaku class combined speed, range, and a large air group. The British Illustrious class used armored flight decks that could withstand bombs better than other designs. Carriers at this level operated in coordinated groups known as carrier task forces. They used fighter screens, reconnaissance patrols, and multi-wave attacks to control large ocean areas. Aircraft improved rapidly, gaining more speed, more payload, and better survivability. These ships faced real threats. Dive bombers and torpedo aircraft could cripple a carrier. Submarines posed a constant danger. Damage control became a vital skill because fires and explosions could spread quickly. Level 3 carriers proved that air power could decide naval battles. The sinking of battleships and the success of large carrier engagements shifted naval doctrine permanently. This level defined the classic fleet carrier, built for large-scale war at sea. Level 4, post-war carriers. Level 4 includes carriers built after World War II and during the early decades of the jet age. These ships had to accommodate faster, heavier aircraft. They introduced angled flight decks, stronger catapults, and better arresting gear. The British MS Ark Royal 1955, the American Midway class modernizations, and the French carrier Clemenceau are examples. These carriers adopted angled decks that allowed aircraft to take off and land at the same time. Jet fighters and strike aircraft demanded more deck space, stronger structures, and more advanced operations. Catapults improved dramatically. Steam catapults allowed heavier jets to reach takeoff speed. Arresting wires became stronger. Flight deck crews developed new safety procedures because jet exhaust and high landing speeds increased risk. The carriers in this tier carried a variety of aircraft, including fighters, attack jets, and early airborne warning platforms. They supported Cold War missions, patrols, and regional conflicts. Level 4 ships were more capable than wartime carriers, but still limited by their size and technology. Their sensors, radars, and communication systems were early examples of what would later become standard. They represented the transitional phase from propeller-driven aviation to full jet operations. Level 5. Modern conventional carriers. Level 5 covers the carriers built from the 1970s onward that used modern aviation technology but relied on conventional propulsion. These ships combined strong air wings with long endurance and improved electronic system. Examples include the British Invincible class, the Spanish Juan Carlos I, the Italian Cava, and the Indian carrier Vikramaditya. Many of these carriers used ski jumps to launch short takeoff jets, such as the Harrier or the F-35B. These carriers focus on flexibility. They carry fighters, helicopters, and sometimes tiltrotor aircraft. Their sensors and radars are modern. Their defensive systems include missiles, guns, and electronic countermeasures. Their flight decks use heat-resistant materials to support jet operations. The Invincible class, for instance, supported Harrier jump jets during the Falklands War. The Cava integrates amphibious capabilities. The Juan Carlos I serves as both a landing helicopter dock and a light carrier. These ships support peacekeeping missions, regional defense, and joint operations. Level 5 carriers are smaller than the nuclear-powered supercarriers of Level 6. They lack the same sustained sortie rates. Their storage capacity and fuel supply are more limited, but they are far more advanced than earlier designs and serve as key assets for many navies. This level highlights the importance of modern multi-role carriers that use updated technology while maintaining practical size and cost. Level 6. Nuclear-powered supercarriers. Level 6 includes the largest and most capable carriers currently in full service. These ships use nuclear propulsion, operate catapult-launched aircraft, and carry large air wings capable of sustained operations. The Nimitz class and the newer Ford-class carriers of the United States are the defining examples. They have unlimited range due to nuclear reactors. They support high sortie rates. They can carry more aircraft, fuel, ammunition, and supplies than any other carriers today. The Nimitz class has served for decades and continues to operate with upgrades. It carries strike fighters, electronic attack aircraft, airborne early warning aircraft, and helicopters. The Ford class introduced new technologies such as electromagnetic catapults, advanced arresting gear, and improved radar systems. Its design reduces crew workload and increases efficiency. These carriers act as floating airbases. They support operations across the globe. They project power, enforce no-fly zones, conduct strike missions, and provide humanitarian aid. Their ability to launch a wide variety of aircraft and maintain high flight tempo sets them apart from conventional carriers. Level 6 carriers require large support fleets. Their construction and maintenance are complex, but their capability makes them the centerpiece of modern naval strategy. Level 7. Next generation and autonomous carrier concepts. Level 7 focuses on the future of carrier aviation. These are the designs and concepts that aim to redefine naval air power through automation, new propulsion systems, advanced sensors, and unmanned aircraft. Examples include the proposed American next-generation carrier, often referred to as CVNX, French and German joint carrier concepts, and early designs for hybrid carriers that support large drone air wings. These carriers aim to integrate unmanned aircraft as core components. Drones would handle surveillance, strike missions, refueling, and electronic warfare. This reduces risk to pilots and expands the number of aircraft that can operate at once. Designers are exploring electromagnetic launch systems for drones, modular hangars, and compact maintenance facilities. Some concepts reduce crew size through automation. Others focus on energy efficiency and hybrid power systems. Stealth shaping plays a role. Future carriers will need to manage radar signatures and electronic emissions to survive in contested environments. Their defensive systems will rely on integrated sensors, advanced interceptors, and more capable electronic warfare tools. Level 7 represents a shift in how carriers fit into the broader battle network. Instead of relying solely on large manned aircraft, these carriers will manage mixed air wings that include autonomous and remotely operated platforms. Their design philosophy focuses on flexibility, survivability, and information superiority. This level points to a future where carriers remain relevant by adapting to the increasing complexity of modern warfare.